Okay, so what I want to look at in this lesson is the idea of what are known as causal relationships and how that relates to correlation. So we have causal relationships. Causal relationships and correlation. Okay, so let's just draw some graphs. Okay, so we have two graphs here. So we have our x value and we have our y value. So x and y. So let's say it's just going from low on this side to high on this side. And the same here, so low to high. So if we think about something, so we talked about this idea. So let's say the sale, so ice cream sales. And then temperature. Degrees Celsius. Okay. So let's say if we have something like this, okay, and it has a fairly strong positive correlation. So this here, if we were to draw a line through it, we can see that it has a it'll have something like a fairly positive, a fairly strong, or not strong, but a positive correlation. So what seems to be happening is that as the temperature increases, so as it gets hotter, the number of ice creams being sold increases as well. Now that's correlation. Okay, so there's correlation between the temperature outside and the number of ice creams sold. Now, is the increase in temperature causing the increase in ice cream sales? So there is a strong argument for not only a correlation but also a causal relationship. So as the temperature increases outside, people get hot, they want to cool down. It kind of pushes them, if you like, to buy ice cream. So you can say in this case that there is a fairly there's a positive correlation, but then that the relationship is causal then as well. Okay, because these two, so this variable here, temperature, impacts this variable here, ice cream, and in this case it ice cream sales, and in this case it impacts it in a positive way. So we say that when a change in one variable causes a change in another variable, we say that there is a causal relationship between them. So in this case, when there's a change in this variable, it causes a change in this variable. Now, something like another one that we could look at, so we might think about, let's say if we had, so let's just anything at all, so number of cars sold. And you could say, so number of cars sold and let's say number of houses sold. And so you might get something that's like this. So we can see in this here, if let's say we have data something like this. So we can see that there's a correlation, okay, but you can't really stand over to say that the number of cars sold, how many cars are being sold, is impacting the number of houses being sold. there's no real causal relationship between those two. Even though there is a positive correlation, okay, like this. Now, the data may not be like this, depending on what I'm just making this up. But let's say you could have something like this. Just because there's a correlation doesn't mean that that the change in this variable affects the change in this variable. So that's what we mean by, like, when we talk about causal relationships and correlation. Now, generally, you can, when you have a fairly strong positive correlation, you can start to kind of start thinking about things like a causal relationship, like one causing the other. Like some other examples then, let's say, of ones that are definitely a causal relationship. If we had something like this, so let's say we have, so age, let's say we had, let's say the age of the car and the value. So imagine we start, so let's say we start from a low value, like let's say high value up here, or sorry, let's say we start with value up the top. So let's say just we start up here, age is low, okay, so it's a fairly new car, and then as we go down, the age increases. So we're just flipping around the way that the data is, like the pole, let's say, on the y-axis. And then let's say the value of the car, so let's say it might be from high to low. So just kind of changing this around. So what you will find is that, let's say, a brand new car is going to be worth, its value is going to be high. And then as you go along, as the car ages, now it's not the case with every car, what's going to happen is it's going to depreciate in value. So the value of the car is going to depreciate. So what we can do is, now again, there are exceptions to that. You have some classic cars and other types of cars that people want, which it'll help them to keep their value. But if we think about this just in general, what we can see is that as the age of the car increases, so it's starting here, it's fairly young, and then it's old here. So when it starts off, it has a high value. Okay, so you can see here, so if we have a fairly high value, but as it gets older, what you can see is that the value starts to depreciate. Now this here is definitely an example of a causal relationship. So this is a causal relationship. And there's also correlation as well. So in this case, there's like fairly strong, like strong negative correlation. So again, like this here would be an example of a causal relationship. So the age of the car is directly impacting the value of the car. So the change in the age is causing the change in the value. So again, this is an example of what we say like a causal relationship. So that's what we mean by causal relationships and correlation. So let me see. So I guess the important kind of take-home message from this is that when you have correlation, so when you have a strong positive or a strong negative, or if when you have the when you have like a perfect negative or a perfect positive correlation, or the correlation coefficient is closer to 1 or -1, that indicates that there is definitely correlation, and correlation can point towards a causal relationship. but you have to investigate it further. So when you have correlation, you might have causation, or you might have a causal relationship, but it doesn't guarantee that you have a causal relationship. Just because you have it looks like one variable is impacting the other, it may not be impacting it at all. It might be something completely different that is impacting it. So it's very important to kind of, to look at the two variables in more detail and look at it a bit further as well, and kind of come up with a logical reason why, or an explanation as to why you think one is causing the other. Um, like if we think, if we think about this one here, so number of cars sold and the number of houses sold. So you could, when you plot it out like this, you could have even a really strong positive correlation, but it doesn't mean that that's causing it to happen. So that's just something really important that you need to. That's like very important in relation to causal relationships and correlation. So I guess the take-home message is that correlation does not necessarily mean that there is a causal relationship. So that's I guess the kind of take-home message in relation to this lesson. So I hope that makes sense. So that's the difference between correlation and causation, and the relationship between the two as well. Okay, thanks guys.